Okay, this is lesson 14 on coordinate proof, and we're looking at the cool down right now. The cool down is named that quadrilateral. So Diego and Noah are reasoning about this diagram. Diego claims that he can tell using slopes that this quadrilateral is a parallelogram. Noah looks at the slopes Diego calculated and says he could be even more specific and call it a rectangle. Do you agree with either of them? Explain or show your reasoning. First of all, we're going to underline or highlight the word parallelogram, and we're going to write a property of a parallelogram that we remember to help us. So we can say, in a parallelogram, opposite sides are parallel. Next, I'm going to highlight opposite sides, and I'm going to calculate the slopes of each side length. All right, so let's take a look at Diego's claim first, saying that the slopes of this quadrilateral makes it a parallelogram. Do we have opposite sides that are parallel? And just remember that if opposite sides are parallel, that means that they have the same slope. So I'm going to write here that opposite sides have the same slopes. And this is really important here. So let's take a look at the slope of line segment XW, which is my yellow line segment. And I'm going to count rise over run, forming that right triangle here. My rise is 3 and my run is 2. So my slope is 3 over 2. Now let's take a look at line segment YZ, which is the green line segment, and let's calculate that slope. And if Diego is correct, I should have opposite sides with the same slope. That means that they are parallel. So I'm going to draw that same right triangle here, and I'm going to calculate rise, which is 3, over run, which I have 2. So right now, it looks pretty good. They do have the same slope, so I know that those two opposite sides are parallel. Now let's take a look at the slope of line segment WZ. I'm going to draw that right triangle here. And we're going to calculate rise over run. So we have rise 1, 2, 3, 4, 5. And actually I'm going down 5, so it's going to be negative. And I'm going to calculate the run. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have a slope of negative 5 over 16. Negative 5 over 16. So this was my red line segment. And I know it's a negative slope because if I put my person on the left-hand side, it's sliding down. All right, now time to check the slope of the blue line segment. So this blue line segment I have rise over run again. And I'm going to calculate the rise, which is 1, 2, 3, 4, 5. So I'm going down 5. It's also a negative slope because if I put my person on the left-hand side again, it's also sliding down. And I'm going to calculate my run. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the slope of line segment XY is also negative 5 over 16. So now I showed with mathematical evidence that opposite sides have the same slope. Therefore, they are parallel. And this makes it a parallelogram. So Diego is correct, and we're going to write a statement right here that says Diego is correct. The quadrilateral is a parallelogram. Because opposite sides are parallel. Opposite sides have the same slopes. And I can even be more specific, and I can refer to line segment XW and line segment YZ, and I can say that they both have a slope of 3 over 2. And let me color code this before I move on. I can say that line segment WZ and line segment XY both have a slope of negative 5 over 16. And let's color code those line segments so you guys can see that very clearly. And next we're going to see if Diego is correct. Diego said that, oops, sorry, not Diego, Noah. Noah then looked at the slopes Diego calculated and says he could be even more specific and call it a rectangle. So we're going to take a look at this and underline the word rectangle. And what we're going to do is we're going to recall a fact about rectangle. So we're going to say in a rectangle, there are 4 right angles. And I know that right angles are formed by perpendicular lines. And specifically, we have line segments here. And they have opposite reciprocal slopes. So what we're going to do right now is see if adjacent sides have opposite reciprocal slopes. And adjacent means right next to each other. Alrighty, we're going to take a look at our adjacent sides. So the adjacent sides to the yellow line segment will be the red and the blue line segment. And we're going to see if it creates right angles right there. It will create a right angle if they are perpendicular lines. And the only way to get a perpendicular line for those to be perpendicular is if they have opposite reciprocal slopes. So looking at the yellow line segment, that slope is 3/2. If it was the opposite reciprocal slope, the red and the blue line segments should both be negative 2/3. And they are currently not negative 2/3. So even though they look like they could form right angles, right, it's actually so close, but they're not right angles. And also, I'm taking a look at my green line segment of 3/2. Its adjacent sides are the red and the blue line segments as well. So if the red and the blue line segments are perpendicular to the green line segment, they would also have opposite reciprocal slopes, forming a right angle. So it should have been a slope of negative 2/3. And again, they are not. They are currently at negative 5/16. So we're going to complete our coordinate proof by stating that Noah is incorrect, unfortunately. So I'm going to continue my proof right over here. I'm going to make an arrow. And I'm going to say, however, Noah is incorrect. By saying it's a rectangle. It's not a rectangle. Because adjacent sides, meaning sides right next to each other, are not perpendicular. So this upside down T again means perpendicular. They do not have opposite reciprocal slopes. I'll continue here. All right, and there we have it, the full coordinate proof for this cool down. Again, this is in Unit 6, Lesson 14 on coordinate proofs.